So we are back at 3D printing. This time I print for the automated greenhouse part 2 video. I finally got around to it. Those prints are, not sure if you can tell it yet, but that behind what is printing right now is a gear, and that is kind of a system for this gear. And here on the Prusa Mini we got a motor holder which will be mounted to a window. So this is basically a motorized window opener. And what that looks like when it is finished, right now it is printing because it has some slight alterations. This is the prototype. So here we will put the motor in, and then here we got some holes to secure it to the window. So basically this will sit here, and here we then got the motor with this gear, and this gear will be here. And now we got this ingenious construction of mine. It's not really ingenious, but it will hopefully work. As you can see here, as soon as the gear rotates, it will move this slider here, and this slider will be placed inside here. And then we got this gear here, and on top of that is a top piece, as you can see here. And the principle is, as soon as this will then rotate, it will either, doesn't work that well if it's not properly secured. It will either move this, let's take this off, it will move this thing upwards, pushing the window open, or it will rotate downwards and thus, through the weight of the window, close it. And with the weight of the window, I mean here will also be either glue or something to stick it to the window, so it is basically forced to follow this slider. And yeah, I actually came up with this idea, like this idea is not new, but I did the mechanical design by myself, and it's not perfect, but it could be worse, and I hope it will work out just fine. So yeah, I will finish printing that and then do some testing. So here you can see the prototype for the Greenhouse Part 2 video. Don't be afraid, something will move in I don't know how many seconds, because I just activated a downlink from the Things network side to this LoRa board, and it only gets this message when it sends out messages, and that is every minute. So this thing should move sometimes, because this is basically the prototype for my motorized window opener. Here you can see this is the linear rack which will move, and here we got a DC motor with a gear. It's all 3D printed. Yep, that was the moment it moved. So this was the movement for, I think, closing the window, and then the other direction is opening the window. And of course you cannot go twice the closed direction and twice the open direction. You always have to alter. So it is important that you do not hit the limits here, because then it is possible that something will break. And I didn't include limit switches, but for such a simple task, we will probably use this area to this area, and I do that with a delay. So that should work for a greenhouse. It's nothing super special, spectacular, but yeah, that should work. And here, as I said, is the LoRa board. It is the same that is in my greenhouse right now, and I basically connected it to a small H-bridge driver. This is the L293. And all it basically does is controlling the driver and saying whether to turn the motor left or right. And depending on what data it gets through the LoRa communication from the Things network side. The indicator in this case is the payload, how big it is. So if the payload is 1 byte, I think I said this thing will close the window, and if it is 2 bytes, it will open the window. So this works out perfectly fine. I'm actually surprised how well this turned out. And I'm getting to the end of this prototyping stuff. I will now go into my garden and mount everything, test everything, and I hope this will work out just fine. So look forward to the video. So for today's shoot, I am in my kitchen, and here's the big quiz question for you. I'm currently preparing broccoli. So what does broccoli have to do with electronics, you might ask? Well, it is actually a quite interesting topic for the next video I'm working on. It is about energy harvesting, which is certainly not free energy. I just want to make it clear, it's not this, how's it called? The machines they build with the free energy devices, perpetuum mobile, where it creates more output power than input power. That is bullshit. This is not bullshit. This is free. This is energy harvesting. So, and this is just an example from a household, which I will take as a real life example, in which, for example, you prepare a meal or something, and as soon as that is done, of course, my stove will still be hot for quite a while. I think for half an hour there is still a bit of a big temperature difference, and energy harvesting is pretty much about using such byproducts of energy and trying to convert that into electrical and then using that for low power systems. So this is a small experiment, just trying out whether I can use the excess heat from my stove to create some electrical energy to power something. It doesn't have to be big, just a small thing. Like I said, it's for low power devices. So this is how I end up in my kitchen for an electronics project, just filming broccoli. But yeah, fun fact. As you can see, this is the second example for the energy harvesting video. I moved my camera here and I just did a bit of testing. And as you can see, this is my washing machine, and the energy we want this time to convert into electrical energy is basically vibrations, which you can see definitely exist. There are quite a few vibrations, and that is something that happens with motors in the industry. And as a household example, I thought this washing machine would be appropriate, because what do you do with this vibration energy? It just goes to waste. So turning it into electrical energy was the point here. And here we basically got on the side a piezoelectric disc, a small full bridge rectifier, and then a capacitor on the top to store the energy. And yeah, so far the results were not that great. I actually wanted to light up an LED constantly, but that didn't work out. So, but it was still able to charge up the capacitor a bit. So, for an example, it will be fine. It's not the best. The other energy harvesting example with the Peltier module was better. But yeah, it was just an experiment to see if that is possible. And I guess you can scale up this setup with more piezo discs or placing them somewhere else. I think this vibrates a lot more than this side, so you can play around with that. But I still think it was rather interesting to try that out. And yes, you will see it in the video what the results will be. So here I am. I'm currently doing a voiceover. So this is my totally professional setup. It's just a microphone in my closet because it's great acoustic in there, and I got my laptop here, which is directly plugged in, and I was having weird problems which I think are interesting to share. As you can see here, I use Audacity, the software Audacity, and you can see here is where the problem started. Everything was normal. I think a couple seconds before, you can see that when I don't speak much here, it's pretty much zero. It's nothing. But at some point, it started to record this weird waveform, which is like a hum. And I was like, this is crazy. Where is this coming from? I don't want this. So I started replacing cables. Maybe I thought about getting a new microphone. I was like, what's going on? And then I realized it. The problem was immediately solved as soon as I disconnected the power. So I think this is a very good example for EMC problems. If you have not seen my video about it, feel free to watch it. It will explain a lot. But basically speaking, there are just interference noises injected into the laptop, and probably with the ground reference not being perfect, it started to create this kind of distortion noises. So yeah, cool example. I wish I had this example when I did the video, but the video still had a really good example. But yeah, that is such a case where electromagnetic compatibility or interference is very important. So thankfully I have a filter laying around in the other room. Maybe I will use that, try that out for the next time. Or, you know, it's a laptop. I will just not plug it in. But yeah, I think I got my solution now. And maybe you learned a thing or two through this video. So here's a small update on what I'm currently working on. As you can see, once again, 3D printing. I didn't do 3D printing at the beginning when I started this channel, but now 3D printing is so accessible. I got 2 3D printers, so why not use them? I think they're getting more and more common, more mainstream, so I love using them. You can do so much with them. So here's a good example. What I'm currently printing here is made of protopasta, I think it's called. It's basically a filament which has iron in it, so it rusts, and more importantly, it can stick to magnets. And what I'm printing here is actually a new core for a rotor, a motor rotor actually. Not sure if you recognize this. This is from the asynchronous motor video or induction motor video, however you want to call it. And here was actually the squirrel cage. I know Germans cannot say squirrel properly, but I'm trying my best here. You know what I mean? It was actually this, and I wanted to get it. Well, first off, I just wanted to add magnets to it. I basically wanted to remove a bit of the material, but then I cut into it and I noticed it is massive. Like, it is completely a solid piece of metal, and there was no way I could. I think I had to get rid of 5 millimeters of this material, and there was no way this was gonna happen. So I decided to cut into it onto both sides, first off with a small angle grinder and then with a big one, because this took forever. And I got it off here, and as you can see, it still looks good. Yeah, there are some scratches, but this will definitely work. And what I'm doing now, I modeled a new kind of like this part in 3D, but with pockets for magnets. So I can basically create a new kind of cage here with magnets inside. And why magnets? Well, what do you think? Why magnets? I'm not telling you right now. I will show it maybe in another small behind the scenes clip or then in the final video. But yeah, adding magnets to it is right now the thing I'm working on, and I think it will be very interesting. But you will see some of it later. So here is the next project, kind of project video I've been working on. Long story short, it's been a complete mess. So the premise of the video was basically using this induction motor, which you might remember from a previous basics video, in which I talked about asynchronous motors and induction motors and how they work. And the premise was to turn them into a generator. Of course, using them as they are as a generator is not really useful, because in this case they don't have magnets. So when you turn them with a low RPM, no magnetic fields will cut through the coils, so no voltage will be induced, and it doesn't work. So I basically modified this one. I added the magnets, and right now I'm doing testing. And the problem for this project was not only that the results are terrible. I will say just like that. It's possible. It does create a voltage. If I turn it here, you can see it. There is a voltage being created, and right now I have an LED here. And if you use something like a drill, hopefully you can get it to work with one hand. Yeah, you can see it's creating voltage, and you get a bit of current. The LED lights up in the end, but really, if you use so much energy, you get so little out of it, it doesn't make sense. So you either have to use more magnets, do another construction of the rotor, I will talk about that in the video, or rewind the motor. So in theory it does work, practically it's not that simple. So that will be the conclusion of the video. But that was not the only problem. I also wanted to had a coupler to connect this to a bicycle, and I actually want to turn it with a bicycle to create something like a bike generator, but that didn't work out as well. You will see it in the video. Long story short, it's been a complete mess, but hopefully I still decided to make a video on it even after all those failures, because I think it is rather interesting, and it pretty much gave me the idea now to work on a proper bike generator which can output way more power, hopefully, maybe something like 100 watts, so you can truly charge something up with it. But we will see how that will turn out. So yeah, that's the project that I've been working on, and the video should be done soon.